My name is Søren. I work at a place called uCommerce. I work at a place I also helped found. We do e-commerce for Umbraco and other CMSs. We've been at this for years and years now, since 2008 actually, since version 3. Lasse over here is a co-founder, and he did the very first version on Umbraco 3. Everything was blue back then, and apparently still the case. I'm not here to talk about uCommerce, but I am here to talk about a principle that we use at uCommerce that we call Framework First. This is basically the way that we build software, and this is a sort of a set of techniques and principles that we build up over time to actually help us create better software. It is based on industry standard patterns and practices and things like that. We've just pulled it all together and made a nice little package on it, and as principles go, you can just come up with a word and just stick first behind it, and you have an awesome principle you can go out and talk about, right? So that's what we did. What I want to do here is I want to talk about how you can create more durable software, so software that will stand the test of time, essentially. So when we're building code, we tend to build up some stuff, and then maybe 2 years down the line, 3 years down the line, if everything is awesome, we rebuild the hell out of that and build it one more time. What Framework First is all about is creating durable software that you can actually modify over time, slowly and steadily evolve so it becomes better. That's the idea. The reason I want to share this with you is because when I see a piece of code that's designed using this type of this approach, it makes me feel all giddy inside. Actually, it makes me feel a little like this. It's like, it's just, you know, there's a reason I call this object-oriented works of art, because I really mean that. When you have something that clicks together and you create something that sort of, it solves the problem, but it also solves it in an elegant way, it clicks together and you can reuse parts of it, that's one thing right then and there. But when you look back, like we can do now, after many, many years of doing this stuff, is this confusing or not? We can actually look back on a series of frameworks that we've designed, that we built in 2008, that remain the same today. No change at all. I think that's a pretty cool thing. It's not that often that you design something that actually sticks and continues to make sense. The problem is, a lot of the techniques that you need to use to get there, it can be a little daunting. So the solid principles, for example, it's something that's really near and dear to my heart. How many of you know about that? Solid principles? No? You will. Dependency injection. Yeah, half-ish. Inversion of control. Inside-out design. That's something I just came up with this morning, so you couldn't possibly know. Well, the thinking is actually in lean and all that, it is actually exactly a thing. Yeah. The problem is all these things, as I'm trying to illustrate here, is something that doesn't make you feel like this. It's more like this. Right? It's a lot of stuff. It's a lot of stuff that you need to know, and it's not necessarily easy to incorporate into the way you think. So what I'm here to do is help you make the picture sort of a little simpler, a little less daunting. I'm trying to create a situation where we have rainbows and unicorns. I didn't do this. Mine would look much worse. So basically what I want to do is today, I figured, this is almost the last slot of the day, so I figured, why not spend the most time in Visual Studio? Just creating code for you. I know you love looking at somebody else creating code, right? Yeah? So what I'm going to do is I'm going to explain all these principles to you, but not just by explaining, but actually showing you how we can take one piece of code and transform it into another piece of code. And we're going to help each other doing this, so it's not just going to be me that will be writing code up here. Well, I will be the only one writing code, actually. But you will help me in what I need to write, okay? Actually, maybe I will pick somebody out. But first, why should you care? Well, durable software, I think that sort of speaks to itself. If you can build software that is durable over time, you don't have to rework it, you don't have to approach your clients and say, hey, we need to rebuild this thing, it sucks. You can actually continue to add value on top of the frameworks that you create, right? Also, it makes for testable solutions. so you can actually improve the quality of what you deliver by automating tests. This is actually where my own journey started with this. Back when I was a consultant many years ago, I worked at a place and we built software like you build software, right? But the quality we outputted was not amazing. In fact, we had a lot of bugs that sort of trickled down to the customer, and then they found it after a week or something like that when you deployed. It wasn't a huge problem because you could turn around and fix it really fast. But it is a problem when your customers become your QA department, right? That's not really where you want to be. So I realized maybe it makes sense to try and test this a little more by means of automated things. But it turned out you can't really test software unless it's built on a very specific set of principles that we're talking about today. Okay? There's also another really important thing. You don't have to believe me that it's important. You just have to believe Microsoft, because they are doing this as well. ASP.NET 5 will be completely dependency injected. It will be completely inversion of control, things that we will be taking a look at today. So whether you want to or not, you will come into contact with this. So you might as well just jump in the deep end and start learning. Does that make sense? Do you know why they're doing this? They're creating the next version of the .NET framework that is able to run not just on Windows, but on OS 10 and all sorts of other things. And so in order to do that, they actually had to externalize a lot of the underlying things that the different pieces of code rely on. And that's actually also what these techniques help. Is there a question, comment? It's okay, good. Right. If you have questions, by the way, stick up your hand. I love a discussion and challenges and all that, so by all means, go ahead. So the first thing we're talking about is sort of the fundamental building blocks of what we're talking about today. Object-oriented design. It's a little sexy, right? Can you feel it? I know it's not that sexy, but actually when you see it, it's going to start to make sense. So when I was in school doing comp sci and all that stuff, I went through object-oriented design courses. And the thing was, it was super fluffy. It was almost impossible to understand what the lecturer was actually saying. It took me, I think, 8 years to actually sort of have the realization, oh, that was what he meant. And actually what he meant was this: solid. So just want to, again, solid. How many have heard about solid? One person. Excellent. I can tell you whatever the hell I want, and you won't know. No, I'll make sure and tell you the right thing. So the beauty of solid is it's actually 5 principles. Each of the letters stands for a principle that will help you create pretty, beautiful, object-oriented code. So I'll walk you through them quickly. You don't have to understand it all necessarily. I'll show you, but I just want to give you some context. So let's start out here. S is for single responsibility principle. The S is super important. This talks about a piece of code that has one responsibility. So imagine a method that does just one thing. So sending an email, for example. Single responsibility for sending an email would say you have something that generates an email, you have something that sends the email, but you don't do both in the same piece of code. Does that make sense? What that means is that once you've separated that out, you actually have a content generator and an email sender, and now you're in a situation where you probably, feasibly, could reuse that code in other situations, because probably you will be sending emails in other areas of your application, right? Content generator, maybe we're generating content in other areas. Think about a CMS. It might generate content for pages. It might generate content for emails, right? So it's about reusability and, by extension, durability, because once you have those things and you can start to remix and reuse them in other contexts, you're good to go. The O stands for open-close principle. Basically, what it's all about is your code should be open for extension, but closed for modification. So if you think about Umbraco, that is what that's all about. Think about when you add new data types in there or new pieces of UI. It's open for extension, but not for modification. You are not changing code in Umbraco to create your sites, right? If you are, stop it. But that's open-close, right? And that means you don't have to deal with how pages are actually created. Umbraco does that. You just use the thing by adding extensions in. That's effectively what your pages are, extensions to Umbraco. Make sense? Good. Liskov substitution principle. She's my favorite lady, Mrs. Liskov. This is a little hard to explain, but if you think about what the bits and bobs you have in code, you have classes, you have interfaces, you have abstract classes. These are what I like to call explicit contracts, right? These are agreements you make between the bits and bobs that make up the code you write. If you have an interface with a method on it, somebody else will have to implement that. They can't not do it, right? Explicit contract. Liskov is completely the opposite. This is about the implicit contracts that you make with the code around you. So if you write a thing, I do e-commerce, so I'm all big about prices and taxes and stuff like that. So imagine you write a thing that always calculates prices that are positive. That makes sense, right? You should usually pay something for an item. That makes sense, right? So the Liskov principle that you have to adhere to there is if you create multiple things that can calculate prices, they should always return a positive number. If you start to return a negative number, you're breaking Liskov, because the surrounding code will assume positive numbers and might not know how to deal with that new situation. Or if you start throwing exceptions, if all the other ones say, well, if I can't calculate a price for that thing, I'll just return a 0. That's the Liskov principle that you need to adhere to in that situation. If you throw an exception, everything will break, right? So you should continue returning a 0. The difficulty here is that it is implicit. You cannot see it anywhere in the code. You have to know. And how do you know? Unit tests, for example. Specifications. Pre- and post documentation that tells you if you stick this in, you'll get this out. Or in Java, for example, you have it actually built into the language where Java will actually explicitly say, it's just one example of it, which exceptions this code might potentially throw. And so it becomes an explicit thing, part of it, but the other part of it with how the code actually acts given different types of input, you can't actually do. Does that make sense? You'll see it. I know this is a fluffy one. This is something that needs to sort of gel around a little bit before it gets going. I here is interface segregation. You can think of this as single responsibility for interfaces, coding interfaces. So your interfaces should have a clear responsibility. What it usually translates into is that you don't create interfaces with a ton of methods on it. You usually create interfaces that specify maybe 1 or 2 methods. But when you go beyond, you're breaking the interface segregation principle. The point is, again, you want your interfaces to be reusable in different contexts, like our single responsibility classes. Right? Dependency inversion, the D. This is about coding against the interface, not the implementation, right? So rather than saying new something something and then coding against that, that will effectively bind you to that one implementation, and so you can't swap it out. So you want to code against the interface instead. Whatever, price calculator. You don't want to specify exactly which price calculator. Imagine if you go back to e-commerce again, maybe the price rules for calculating an item price is different in Germany from Denmark, or taxes, right? They're completely different in the US and in Denmark. So you want to be able to swap out the implementation depending on the situation. If we code against the US tax rules, the German tax rules, or the Danish tax rules, we would have to pick one, right? And we could never change it out. So that's what the D is all about, dependency inversion. Code against the interface, never the implementation. I'll show you exactly how that could be done. Dependency injection. This is about clicking things together. So I got a lot of nods on single responsibility principle. When we have classes that work together to solve the problem, the next logical thing that needs to happen is you have to click them together to make them work, right? Let's go back to our email example from before. If you have a thing that sends email, it needs a thing that can generate content for that email. So probably it needs to be injected into the sender so it can actually generate the email and then send it. Does that make sense? It's about orchestrating all the little pieces that you create. Concretely, it's all about a constructor that takes another object and you're done. I'll show you how it works. Inversion of control. This is the next logical step of that. So when you have things that are injected through constructors all over the place, you can get really big constructors that accept maybe 10, 20 different arguments. So getting an object up and running by newing it up will actually require you to new that up and then new up 20 other things and push them into the constructor. So it becomes a little cumbersome. And what happens? You're actually coding against the implementation, not the interface, because you have to new up classes. There's also a way around that. I'll show you that. This is where we switch into Visual Studio and go into demo mode. And this is what I'd like you to see, but sometimes reality is a little different. So we'll see how that goes. This is where I hope you'll help me out. Coding live is very difficult. I will screw up, as the GIF indicates, so please help me out. What I'm going to do is I'm going to show you a piece of code of what code looked like before I learned these principles. Visual Studio for the win. So we haven't seen too much Visual Studio today. There it is. This is what it looks like. Huh? Good. So what I have here is I've just nicked some of our training code and added some stuff in. But basically what it is, it's a little program that runs some code. That's it. So a console app, and from there we'll build it up. So what I've done already, is this big enough? Can you read it all right? Also in the back row? Yes. Good. So what I've done is I have created a little program. It simulates a checkout, because again, we do e-commerce, so it's an area I know very, very well. And the code looks like this. I need my laser here. So basically, this is code that violates every single principle I've just talked about. So what we're going to do together is, I've explained the principles to you, right? So now you can help me out actually refactoring this code so it becomes an object-oriented work of art. Can we do that? Maybe. We'll see. So let me just walk through it. Checkout, right? When you check out in a web shop, you've all tried that. Anybody who haven't tried to buy anything online? Nobody? Good. Okay. I just wanted to check because I want a conversation with that person after the fact. I think that would be interesting. Okay, so checkout. Imagine what checkout could do. It can do all sorts of things. I just picked 3 things, right? So you can see here at the top, I get a purchase order in. That's just to keep everything nice and tidy, so we can focus on this one code block and what we do. So first, I validate that we have payment. So basically, I take a look at an order, take a look at the order total, sum up the payments that have been made, and see if I have enough payment to cover the total, right? So imagine you whip out your debit card. We check that, if you actually have enough balance. So that's the first piece. Next piece is that I assign an order number. I just create a little method to make it not too messy in here, but we assign an order number because that probably also happens on checkout, right? And finally, I actually send that email. So you can see that's the bulk of the code. I set up an email, send it out to billing, and that's it, right? Send it out via SMTP. Let's see if I have my little mail server running here. I do, so let's try and run this code. Up here, I have the harness for running it. So we'll take a look at that real quick. What I'm doing is I'm basically just setting up an order, populating a few fields that I need, and then I pass it in, and then I see if my code said, yes, it went well. So now we can execute this, hopefully. This is where we cross our fingers. I can see already I have a boo-boo up here. Sorry about that, just want to get rid of that. Right, and if everything goes well, we'll get an email down here. All right, so a piece of code, it's written in a certain way. Now we need to observe the solid principles, and we'll start with S. So we need to take a look at this code, and we need to refactor it so it becomes prettier, and so that it observes the S, single responsibility principle. Anybody care to give me a pointer on how we might go about modifying this so everything gets one clear responsibility? Any ideas?
As you said, creating email and sending email out to single parts.
Yeah, so maybe make that into a class or something like that? Yeah?
Yes, of course, because you can use it.
Then I can move it about, right? I have a nice package. It's maybe a little grand, calling one class a package, but it's a nicely isolated piece of code. Any other ideas? Think about generating order numbers. That might actually be different from company to company, right? Some might want to stick some text in front. Some might want to grab an order number from a different system. So it might actually have different sort of behaviors. I've seen companies that only had 65,535 order numbers available because they were using small ints for that. So they had to recycle order numbers. And it was actually a big pain in that company. But they had to do it because that's the legacy systems. They couldn't deal with it. And maybe also up here, there's some validation that's actually, a thing, right? Maybe we would want more validation going forward. So what I can do here is I can start to create new classes that hold all this stuff. And this is going to be real easy. Maybe. Okay. At least it was. So I'll create a new class here. And we'll start out, we'll call this one here validate payment. And we'll call it a task, just because it sounds awesome. Right, so I have a new class here. And I'll be using an interface here that I have already created. So you'll see that in a little bit what that is. But for now, just accept that. It's just a thing I need for a little later on. It's called iPipeline task. So this will make sense very shortly. Oops. Use ReSharper to implement, and that's it. So what I have here is effectively a block of code that does one thing, right? You can read the class name and get a sense of what's actually going on. So it also means that the class, I hesitate to call it self-documented because it usually becomes an excuse to not document. But if I take this piece of code here, just copy that out into my class here. Just change this here, like that. And you'll notice here that it throws an error here, and we can go pipeline execution result success. So this is just a contract. This is one of these explicit contracts I've established. There's actually a listcov in here that I'll talk about a little bit, so you can see that. Somehow that became objects. There we go. Right, so you can see what I've done is, it looks a little like a little much. I've created a class just to host an if statement. But there is a very clear responsibility here. So I can carry on here and create a new one that assigns that order number. So new class. Like that. It will implement the same interface as before, iPipeline task. It will operate on a purchase order. And we'll implement that interface. And what I'll do is I'll basically go and grab the code again from before, from over here, right there. And in this case here, there's actually a little method I need to pick out as well. Stick that in here. We need to change that to order, and go back to my program and grab that little extra method. So you can see how some of the implementation details are also hidden away. So I get a little freedom to do different things. So I just need to pick this up. You can see how my order generation scheme here is. Don't copy that. I have a patent pending on that. Like that. And we'll return a pipeline execution result, and we'll just say that's a success, and that's it. So now the order generation approach has also been factored out, and now I could actually change how I could do that before as well, but I can actually change the implementation here without worrying too much about the surrounding code. The very last thing I need to do is create that email thingamajig. So I'll just add a third class, and we'll call that something like send order confirmation task, like that. Again with the interface, so we're just adhering to some conventions I've set up, just to make it nice and tidy. It needs to be public, and it needs to be implemented like that. Grab my code. You can sort of see the pattern here. Where is it? It's up there. Like that. Implement some stuff. Get this changed to order so it makes sense. That's it. And again, I need to return pipeline execution result. And I want it to be something like that. Right? So now we've separated that out, but I'm not calling it. So now I need to go and refactor my program here. And what I'm going to do is I'm going to drive up here And I'm just gonna call the other one. So what I'll do here is, if you're interested, you can get the code if you want to see after the fact here. So I'm going to leave in all the different mutations of what we're doing. So I'm just gonna build it up so we observe more and more principles, so you can see the transitions from a flat piece of code to a single responsibility piece of code, and so on and so forth. So SRP is SRP. Check out. So we're just observing the single responsibility principle here, and you can probably imagine what this piece of code will have to look like. Basically, what I'm doing here, I'm newing up my validate payment task. I'm executing with that, and I'm sending in the order, like that. And I'm then executing my sign order number thing, like that. Execute order. And finally, my send order confirmation task. And again, execute order done, return true, like that. So you can see how the method changed from being this to being that on the top. But you'll notice what happened actually when it went from the original version to single responsibility. Because what you'll see here is that if you look at this code and you look at that code, which one is easier to understand what's happening? This is what we call in the business a leading question. Is it number 1 or number 2? Who's for number 1? Half, okay. And I guess the rest is for number 2. But what you'll notice here is I don't really need a lot of comments now, because the classes themselves actually tell me at least something about what's going on. Whereas before I had to grok all of this stuff. It was actually only the comments in my code that gave me some instructions on what was what, right? Good. So then next up, we need to adhere to the open-close principle, so to allow you to hook in new stuff, to give you an execution engine of sorts that this stuff will work in, because as you'll notice here, I can still only change this by actually newing stuff up and executing it. I still control the execution flow of this stuff, and I want that sitting in a framework so I can deal with error handling and things like that. So next, open-close principle basically will allow me to add new implementations in that will do more stuff. If you think about business logic, that's what it is, right? If you think about a method, you do this all the time. You add new code to the bottom, to the top, in the middle, wherever. But it's difficult to figure out where it goes and where it makes sense. So the next thing here will be to actually add an execution engine to that. And to do that, I want to do a pipeline. This is a concept we've had. That's actually an example of one of those frameworks we've had in uCommerce forever. Whoops, I want a class here. Did I get a class? Maybe. We'll call it a pipeline. So a pipeline will basically take a series of tasks and execute them. It won't worry about the actual implementation of the task. It will just run with it. And so you can start to add more logic, but don't worry about how to actually execute it. So I'll implement another interface here that I have already. You could also implement from scratch. Basically, this tells my pipeline which object I want to operate on. It has an execution, an execute method, and that's it. So now I need a way to actually figure out what to execute. And this is where dependency injection comes into play. And it's really, really simple. Dependency injection is basically about feeding objects to other objects. So you've done this a ton of times, right? Whenever you new up something and it needs something else, that's dependency injection, basically. So what I'm going to do is I'm going to generate a constructor for you guys. It's going to take a list of pipeline tasks. This is where that interface becomes important. Otherwise, I wouldn't actually be able to do it. It will be of purchase order, and it will be the tasks that I need. And then I'll introduce a variable so I can actually operate on that. And here, I will, over each of my tasks, in tasks, it would actually be the internal variable here. And I would then go and say task.execute. I would give it the payload that I need, which is the subject, so that would be the order. Whoops. And that would be it. Oops, probably not error. That would be a shame. So we'll just go with a simple implementation. So this is the execution engine that I can now start to stick new pieces of code into, and it will do what I want it to do. But the beauty here is I've centralized execution of the code that I have, so I can now go and do other things like measure how long does it actually take to assign an order number. If an error occurs, should I notify anybody? And that can become sort of a shared concern for everything. So now I need to refactor my code from before, and I need to go into my program here and go checked out. Whoops, spelling not great today. So we'll go open, close, shoot. Open, close, check out. It'll still get the order, but in here, I'll do something different. I'll new up the pipeline. And that will be it. Come on. So helpful, Reshapper, but really, no, not so much. There we go. So new pipeline. And the pipeline takes those tasks. You can't see it, but it says so right there. So I'll just send in, actually, I'll just copy-paste a bit of code here. So rather than telling it what to do, I'll just stick my tasks in here. And rather than executing them, because there might be some other things that needs to happen, I just new them up and pass them in. Right? Oops, I need a list for this. So a new list of I pipeline task, and that should be of purchase order, like that, and some constructor, some object initialization should do the trick, like that. And then I can execute this, call order. Oops. Cramped keyboard. All right, so you see the difference now. We're gone from the steps being hard-coded now, down here, into that I can actually start to pass my stuff in as little commands that will be executed, but working on that payload. In addition, the payload that is dropped in is the same, so you can actually mutate it from step to step. And so it becomes open to extension, because I can just add a new thing here, and that'll work, right? But closed for modification, because I will not change my actual runtime to make it go. The pipeline I just created will remain stable. This implementation will remain as is, because there's no reason to change the framework anymore. I just add new bits and bobs in. And now if you think about multiple different types of business logic that you need to do, if you think about the code that you write, you have different methods all over the place. If they are each pipelines, you can start to hook into that and override behavior in certain areas of your system. Just find the right one, hook your stuff in, and you're good to go. Does that make sense? Any questions? No. Now let's talk about Liskov, my old friend, my old nemesis. This is where bugs occur. Typically, this is where those things that take a long time to find actually originate. Because there is no way to see if you're violating the Liskov substitution principle. Basically, the only way that you can see it is by poking it. And by poking it, I mean executing it with some inputs and see what happens, basically. And the best way to do that is unit testing. I won't bore you with setting up unit testing and things like that. But in this case here, a Liskov problem in my task, you'll notice here all my tasks return these pipeline execution results. So they say error or success, basically. But if I were to throw an exception in there, I would be breaking the Liskov substitution principle in this particular set of code because I don't have anything that actually takes that into account. So that's what you see when something starts to return -1 or something random. If you have a web service that just returns JSON, for example, and that format changes all of a sudden, that's breaking Liskov. And your code, as a result, will stop working, right? You've been there, I guess. Okay. Let me show you the final thing, because we have a few more principles to talk about. The interface segregation principle. I'll just talk about it real quick. So in this here, we've been using interface. We've been using this I pipeline task, a generic interface of purchase order. It has one method, execute. And the result of that is it's super simple for me to actually find out what I need to do because there's not a ton of things on there. We've not always been creating code like this. So what is more common to see is you have interfaces with maybe 5, 7, 10 methods on it. But the problem is, if you have to implement one of those as a developer, you need to know what to do in all those, and you probably don't want all of them. Typically, what it indicates when you have interfaces with lots of methods on it is that either it doesn't have a clear and distinct reason for being, or there is an implicit expectation on how methods that implement the separate things of the interface are called, in which order. There is sort of an implicit interaction going on. So we have sort of a rule of thumb, a little bit of a tongue-in-cheek, that say, well, the optimum number of methods on an interface is 1. It's not always the case. There is exceptions. Let me show you the final thing, because there is one more thing, like they say. We've talked about dependency inversion, the act of coding against the interface, not the implementation. And so far, what have I been doing? I've not been doing that, that's for sure. Because I'm newing up classes all over the place. I can't actually go in and change this. I still need to modify code to actually make it change. So this is where inversion of control comes into play to make that happen. Because there's basically no way to do it in code. Well, there is. You can reflect and stuff like that. So inversion of control is basically something that helps you. You'll notice my pipeline up here. This actually has a great example of what we're talking about. In order to get this pipeline going, sorry about that, let me move that. I had to new up 3 other things and a list and stuff, right? That's pretty complicated stuff. Or not complicated, it's just cumbersome, and it's extra stuff that why? It doesn't make any sense. And also, I'm tied to the actual implementations. So what inversion of control does is basically it takes out of the equation the act of finding the implementation you want for something specific, and then newing it up for you, and then giving it to the thing that needs it. So in this case, the pipeline would specify, hey, I need a bunch of things that can act on a purchase order. And so the inversion of control system would go out, find the implementations that can do that, give them back, and now the pipeline can do its thing. Does that make sense? Maybe. So let me show you. I won't code it all up. So there are tools to deal with this. They are called inversion of control containers. You can also refer them to them as dependency injection containers. They are basically like DNS for objects. That's a good way to think about it. So give the object a name, and then you can refer to that name, not the actual thing. And so the thing can change, like an IP address in a website. Does that make sense? So you stick all your components and interfaces into that, and out comes functional blobs of code. The one I'll show you here is called Castle Winter. It is one of the older inversion of control containers. There's a ton of them. Ninject and Structure Map and Unity from Microsoft, Microsoft Extensibility Framework. There's a ton of tools. Pick one. They're the same. There is some differences in performance and things like that. There's a guy that does measurements and all that, so you can find that on the internet if that's something that matters to you. But pick one. Castle Winter is awesome. I know a lot of people that enjoy Structure Map. Go with one. So let me show you what that would look like. Basically, what it's all about is it's about moving the act of coupling components someplace else. Sometimes it happens in what's known as a bootstrapper, so a piece of code that does exactly this, so you would actually still be newing things up or asking for things or registering things. But it's about centralizing that in one spot. You can also do it with XML, as I'm going to show you now. If I can find the right button here. So let me just show you this. I'll walk through this slowly, so you have a chance of understanding what's going on. Good. So we'll actually start at the bottom.
You have to remove the closing command in line 16.
Say what?
16.
Oh, thank you very much. That would have been awkward in a little bit. All right. So what this is it is a component registration. So this is 3 sets of DNS for components. So what it is, it consists of 3 things. Each of these components. So they each represent the classes that I was just newing up. So here, first I give it an ID, so we can refer to it by some means. This means that you can actually start to reason on the component. Sometimes it's used, sometimes not, but it's important that they be unique, otherwise everything will be very weird. So I have my validate payments, I have my assign order number, and I have my send confirmation email. So they represent the functional blobs I was just doing. Now, the next bit is to bring it together. So the next is the service, that's the interface I was just implementing. It is a generic interface, so what it says is, this is the thing that we will be operating on. So in order to observe the dependency inversion principle, I should operate on the interface, but not the class, right? And so that's what I'm doing. This is what we will actually be working on. Next is the actual implementation here, so validate payments task, that's the one I did. It's in my app, apparently. So I have a coupling now between the interface and the method. Same thing for the others, and I'm good to go. These components can now be used by other components. And so if I scroll up, you'll see how we define another component here, my checkout. It has a service and a type, but it also has the dependency injection property that we were doing before, where we were doing things up, new list, da-da-da-da-da. Now we're actually doing it via parameters, and we were saying, well, there's an argument on a constructor called tasks, and that is an array or a list, and that will actually take this component, and that. So these are references to these three things. So this is effectively equivalent to what I'm doing in code over here, but it has the beauty of being, where is it? Over here. Right there, right? But it has the beauty of being externalized from my code. It's now in a configuration file that, guess what? Anybody can change. And so now it's open to extension, but closed to modification. Because you can create your own thing in a different project, in a different DLL, click it into the XML file, and you're good to go. I'm not saying that these principles are for everybody, but what I am saying is that you get a very clear separation of concerns in this. Really important. And imagine if the system changes at some point. Maybe validation of payments is not what I thought it was. So if time comes to change that, I can rip out that one component without actually changing the overall logic, just that one class, adding something different in. Maybe we want to validate, say, not just that you have coverage on your card, but also that you're credit worthy if you're going into a different domain of starting to do invoicing or things like that. So maybe the logic changes. And so you can change that. Just rip it out, add a new one in, or add another one in after this. Does that make sense? So see how you have a componentized architecture here. And the beauty is the pipeline itself is a component. So if you start to write other pipelines, other pieces of code, services, things like that need this logic, ask for it, and you shall have it. Does that make sense? Cool. That is all the coding I think we can manage for today. So back to Visual Studio. So let me just, was it that guy? Or was it that guy? I'm not sure, but let me talk about another way of thinking of this. Because one crucial error I did here that actually made me into the second guy is I designed this bottom up. So I went with a piece of code and I then refactored it until I ended up with where I wanted to go. The reason I did that was to illustrate the point, to build it up not all at once, but in stages so you could see the process, so you can do it yourselves. The problem is that's not how you should actually do it. This is only for educational purposes. What I'm a big proponent of is actually going the other way around. Thinking about the problem you have, thinking from the outside in. Because what I've seen us do, and many other developers do, is we start at the bottom. We think about, okay, which data do we need? What should the database look like? Then we build that. Then, okay, so now we have a database. Now we need to get stuff out of the database. So how do we do that? And then at the end of the day, we get all the way up to the UI. We've done all this stuff. We're a little tired. Frankly, we need a break. So the UI will just get lumped together. It will look like you've thrown it together at last minute, and it won't really be a good user experience. Flip it around instead. And that's what Framework First is also about, that you think about what you want out of it, then you design it, and then you build it top to bottom instead. So if we're thinking about a piece of code that has UI on top, it means starting with the use case, hammering it out, figuring out what should happen, and then build it all the way down. Framework First will totally support it, no problem. But also if you think about it from an API point of view, we're framework developers. And so we'd like to think in use cases for you guys. How would you actually use this API? Which extension points would you need? And this approach will give you that by default. Does that make sense? Good. So I know it's a little heavy. It's a lot of stuff. And it takes a long time to internalize. I will guess that maybe 75% of you are thinking right now, holy crap, that's a lot of stuff. We had this one piece of code, and he turned it into XML files and different classes and all sorts of stuff. And yes, it does look like a lot of stuff. The thing is, the upfront investment that we're doing right now, you do that one time. But what you will continue to do over a long time is continuing to support that code base. And so the modularity that you saw, the clear responsibilities become more and more important. It means you can keep your code for longer and thus create more value for your clients. And actually, it will become second nature. When I started this out, I was the same. I didn't realize that in order to do the testing that got me going, we actually had to fundamentally change the way we do software. But we did it. It was painful, and we observed all this stuff, and we created huge piles of crap, to be honest about it, because we needed to get this under our skins. But today, we don't even have to think about it. It just happens, because it's been internalized at everybody, and so we get extensibility for free, almost. And it doesn't actually add overhead once it's all set up. Not a lot, at least. So we did that, and I just figured it's probably a little overwhelming, so I wanted to give you one thing you could take back and do. One thing that's very concrete, very simple to work with. It does not involve the toilet roll or the cat. Well, maybe the cat, but definitely not the toilet roll. Think back to single responsibility principle. I could see it in your eyes. You were nodding along. You could sort of see the point in that. If you go back and do one thing, start to do smaller classes that have just one clear responsibility. Start there, and then work your way up. Because what will happen is, once you start doing this, the other things will naturally follow. It will be necessary to do some of the other things as well. You don't have to, but you will find that your lives are easier when you start doing it. So single responsibility, a good way to see if you're actually observing that is the name of the class. Think back to the code we did. You could see on the class, not exactly what it did, but the intent at least. It meant I could remove some comments and stuff, but the intent was there. So if you want a litmus test to see if you're there, see if you can just look at that. Also, when you're doing documentation on your code, which we all are, I know, right? XML documentation on everything, of course. You only have to document on the class level, because the class will have all you need to tell you what it does, because effectively what you're doing is you are taking things that are methods today and turning them into classes and then clicking them together. Does that make sense? It's a single responsibility principle. If you do just one thing, that's it. Super easy to work with. You'll have more classes, but you also have ReSharper to navigate that stuff, and it will sort of start you out on your journey here. So with that, thank you very much for listening and sticking with me through all the code. I hope you got something you could use. Single responsibility principle, it's awesome. And that's how we create object-oriented works of art. Thank you very much.